I will ask Alok to join me on stage. He is of Indian descent. His department is Civil, Structural, and Environmental Engineering. Among his passions and his future, he hopes, is research in earthquake engineering. His presentation title is Building Safer Nuclear Power Plants. We welcome you, Alok Deshpande. Deshpande, is that the best pronunciation, Alok? Thank you very much. Again, building safer nuclear power plants. Ready, set, and pitch.
Imagine an earthquake striking a nuclear power plant. How safe do we want that structure to be? Probably much safer than any other structure, because as we have seen at Chernobyl and Fukushima, the impacts of a failure in a nuclear facility can be felt for generations. Nuclear power plants, like other thermal power plants, generate a lot of heat, and this heat is carried to the power turbines using steam pipes. Earthquake shaking has the potential to rupture these steam pipes. If this were to happen, then the high pressure, high temperature steam contained within would spew within the airtight containment structure. Think of a pressure cooker. How would this affect its structural safety? Also, remember that earthquakes are usually followed by aftershocks, which can be just as intense as the main shaking. As part of my doctoral research in structural engineering, I'm studying the effects of these elevated temperatures on the behavior of the structure, specifically on its strength and stiffness and its ability to resist future aftershocks. Since it's not practical to test the structure, though, we structural engineers usually build and test its components in the lab. Nuclear power plants are built almost entirely of concrete walls. So I built concrete wall specimens and subjected them to a wide variety of combined thermal and structural conditions, just as expected in a thermal accident. I saw in these tests that there was a significant reduction in stiffness. But the good news is that there was no reduction in strength, even at temperatures 50% higher than those expected in such accidents. I'm using these observations now to write recommendations that can be used by designers to assess safety of existing plants after such an accident, and also design safer, newer plants. Since the behavior of the structure is defined by the behavior of its materials, I'm also studying the behavior of concrete itself when subjected to high temperatures. This will allow me to better understand the behavior of the concrete walls that I tested. Through the course of this study, and by understanding the mechanisms of damage in concrete, I've developed a new steel and polymer fiber reinforced concrete material. This material performs significantly better than conventional concrete, both at normal as well as high temperatures. Such a robust material has applications in other structures too, structures like buildings, bridges, and tunnels, which can otherwise see catastrophic damage due to fire events. In summary, it's vital to ensure the safety of nuclear power plants, and understanding the effects of elevated temperatures, both on concrete and concrete structures, including the development of newer, more robust materials, are important steps in this direction. And so we can all have a safer nuclear future. Thank you.
Thank you, Alok. I did a live shot for Channel 2 at the shake table, right? Isn't that the shake table, what it's called here? Right, the earthquake testing facility, right? And I actually did a live shot, I believe, at a facility that used that table, Taylor Devices in North Tonawanda. They have used your facility, and yeah, and again, similarly with my live shots, then not that anybody cares, but he described. I said, well, what is this big giant 10-foot thing here? Well, this is a damper, a viscous damper used to absorb the potentially destructive energy that an earthquake or any sort of seismic, hold on. So it's a shock absorber for a building? Yes. Okay, that's what I'm going to say it is. It's a shock absorber for a building. It's just a 10-foot version instead of the little ones you put in your car.